At some point in every human life, usually late at night when distractions finally quiet down, a dangerous thought slips in. You look up at the sky, at those silent, scattered lights, and a simple question forms that has no simple answer. Where does this end? Not just the stars you can see, not just the galaxies we photograph, but everything, the whole universe. Does it stop somewhere, like a wall at the edge of reality? Or does it keep going, forever? The idea is unsettling, almost uncomfortable, because the human brain struggles with things that do not end. Infinity sounds beautiful in theory, but when you try to imagine it, something in your mind resists. This story begins in that resistance. Imagine a lone observatory on a quiet mountain. The air is thin, sharp, and cold. Inside, a scientist stares into a screen filled with light that left its source billions of years ago. That light has traveled across unimaginable distances, surviving chaos, gravity, and time itself, just to reach a mirror, a lens, and finally, an eye. The screen doesn't show answers. It shows questions. And one of the biggest is this: could the universe actually be infinite? For most of human history, the universe felt small. The sky was a dome, the stars were fixed, the earth was the center. That belief wasn't ignorance, it was perspective. When you don't know scale, everything feels manageable. Ancient civilizations told stories of gods building the heavens, placing stars like lanterns just beyond reach. The universe had purpose, design, intention, and most importantly, boundaries. It made existence feel contained. But containment didn't survive the invention of the telescope. When Galileo turned his lens toward the sky, reality cracked open. The stars multiplied, planets revealed motion. The universe was no longer static, it was alive. What followed over centuries was not clarity, but expansion. Every generation thought it was close to the edge of understanding, only to realize later it had barely stepped outside the door. By the early 20th century, scientists believed the Milky Way was the universe. Billions of stars, yes, but still a single island. That illusion shattered when Edwin Hubble discovered other galaxies, each containing billions of stars of their own. The universe suddenly became larger than anyone had imagined. And then something even stranger happened. Those galaxies were not staying still. They were moving away from us. The universe was expanding. This discovery changed everything. Expansion meant motion. Motion implied a beginning. If galaxies are moving apart now, then once, long ago, they must have been closer together. This idea led to what we now call the Big Bang. Not an explosion in space, but an expansion of space itself. Space was stretching, time was unfolding, the universe had a history. Here's where the myth begins. Many people imagine the Big Bang as a point exploding into empty darkness. But there was no empty darkness. There was no outside. The Big Bang wasn't something that happened in space. It was something that created space. Asking what happened before it or what lies beyond it is like asking what's north of the North Pole. The question itself breaks down. And yet, even with this knowledge, the deeper question remains. If the universe began expanding, does that expansion ever stop? Is there an edge to it, a final boundary where existence simply ends? To understand why this is so difficult to answer, we need to talk about observation. Everything we know about the universe is limited by how far light has had time to travel. The universe is about 13.8 billion years old, which means we can only see light that has traveled for 13.8 billion years or less. This creates what scientists call the observable universe. It's not the whole universe. It's just the part we can see. Beyond that horizon, there may be more galaxies, more stars, more complexity than we can ever observe. Or there may be nothing at all. The universe might curve back on itself. It might extend infinitely. Current physics allows for several possibilities, and none of them are emotionally satisfying. Measurements of cosmic background radiation suggest that the universe is remarkably flat. Not flat like a table, but flat in terms of geometry. This matters because a flat universe, according to general relativity, can be infinite. It doesn't have to be, but it can be. A flat universe doesn't curve inward like a sphere or outward like a saddle. It just keeps going. But here is the twist. Infinite does not mean endless chaos. An infinite universe could still follow the same physical laws everywhere, the same forces, the same particles, which leads to a concept that borders on science fiction but emerges naturally from mathematics. If the universe is infinite and matter is distributed randomly, then somewhere, out there, far beyond what we can ever reach, there could be regions almost identical to this one. Not copies in a mystical sense, but statistical repetitions. Another galaxy shaped like ours. Another solar system similar to ours. Another Earth. Another version of you making slightly different choices. This idea unsettles people not because it's mystical, but because it's mechanical. It removes meaning from uniqueness and replaces it with probability. But here's the important myth to bust. Infinity does not mean everything exists somewhere. It only means possibilities repeat, given enough space. And even then, enough may be larger than any number the human mind can truly grasp. Infinity is not abundance. It is scale without offense. There's another misconception worth addressing. People often imagine an infinite universe as something that must feel obvious, sprawling endlessly into darkness. But an infinite universe doesn't feel infinite from the inside. From any point within it, it looks finite, centered, and limited by observation. Just like standing on Earth, where the surface is finite in perception, but part of something far larger. This is why the brain struggles. Humans evolve to understand environments, not infinities. Our intuition works well for survival-scale problems, not cosmology. Infinity doesn't trigger wonder first. It triggers discomfort. The mind wants closure, a final frame, a last page. Infinity denies all of that. Even scientists feel this discomfort. Some theories propose a multiverse, where our universe is just one bubble among many. Others suggest the universe loops back on itself, finite but unbounded. You could travel forever and never hit an edge, the way you can walk around Earth endlessly without falling off. And then there are models where space truly does go on forever in every direction, with no repetition, no boundary, no center. The truth is, modern physics hasn't decided yet. And that uncertainty is not failure, it's honesty. What we do know is this. The universe is expanding faster over time, driven by something we call dark energy. We don't know exactly what it is. We just know it exists because galaxies are accelerating away from each other. This expansion doesn't require an edge. Space can expand infinitely without expanding into anything. Again, this breaks intuition. Expansion feels like motion into emptiness, but in cosmology, space itself is what's growing. This leads to a quiet, haunting realization. The universe doesn't need us to understand it. It operates perfectly well without human comprehension. Our theories are attempts, not conclusions, and every answer we find opens larger questions behind it. At the emotional core of this question is something deeply human. If the universe is infinite, where do we fit? Does meaning shrink when scale grows, or does meaning become more precious because of it? Here's where the story turns inward. Imagine again that night sky. The same stars humans have been staring at for tens of thousands of years. The same question passed down silently through generations. Whether the universe ends or goes on forever doesn't change the fact that you are here now, conscious within it, asking questions that matter to you. Infinity doesn't erase significance, it reframes it. The myth that science kills wonder couldn't be further from the truth. The more we learn, the more fragile certainty becomes, and in that fragility, awe grows. Could the universe be infinite? Yes, it could be. It also might not be. Both are supported by real, serious science. What matters is not choosing the most dramatic answer, but understanding why the question is still open. Understanding that knowledge has edges, just like observation does. The climax of this story is not a conclusion, it's acceptance. Acceptance that the universe may never fit neatly into the human mind. Acceptance that not knowing doesn't diminish us, but defines us. Because the same brain that struggles with infinity is the one capable of imagining it. The same species that once thought the sky was a ceiling now measures the age of light itself. That progress didn't come from certainty. It came from curiosity. And maybe that's the real answer hidden inside the question. Whether the universe is infinite or finite, expanding forever or ending silently,